Yep, good evening everyone. So Johnny comes, let's start off. Chalo, others comes on. We'll be starting with a new chapter, Laws of Motion today. Now, in laws of motion, right, primarily there are two major concepts. One is your constraint motion, second is your free body diagrams. So once you are clear with these two concepts, then we can go ahead with the problems. And then we will see how things move, forces, and all that stuff. So the first part we will handle is constraint motion. So what is this constraint motion? If the motion of a body depends on the motion of other bodies. The motion is said to be constrained. You need to keep your cams on, or else you'll move from the classroom. I won't be repeating it every time when you come to the class. Class starts, you need to keep your cam on. Example, let's say we have a block A here going with some 5 meters per second. And if you take a block B here, now if you look at the speed of B, it can be anything. B and A have no relation to each other. Speed of A can be anything. So basically the motion of A here is independent of B. So basically we said it's not constrained. Neil, to keep your cam on. And now the same thing, if you are taking something of this sort, let's say we have A here and we have a thin rod in between them. Let's say the rod can't break or can't stretch. If you say B is traveling with a speed of 2 meters per second, A doesn't have a choice. Since the rod cannot stretch or cannot break, this A and B should have same velocity. So here the motion is constrained. So the simple way to remember is like this thing. If the motion of, this is the example, like in this case, the first example, no matter whatever is the speed of A, B can have anything. Whereas in this second case, you can't have any speed you want. The moment you decide the speed of B, A ka speed is already decided. Now, so basically what we try to do in this thing questions, right, is simply find relation between the acceleration of different bodies. Now we have in this thing primarily two main methods. One is the length of the string is constant. And the second thing is a virtual work method or a power method. And there's a third one, which it is kind of a version of first method. We'll see later on. It's more of a to do with visualization. That is how I solved most of the problems when I was in 11th and 12th. We will see all those three. Clear with this page? Great. So let's go ahead. Now, again, in constraints, we have two types of constraints, the string constraints and rigid body constraints. String constraints is when bodies are connected by strings. So we will be dealing with ideal strings. What are ideal strings? These are inextensible, matlab they won't stretch. Non-dissipative, mean they do not dissipate any energy, they don't have any friction. And massless. Now the massless can be, need not be, but primarily inextensible and the non-dissipative are the more important ones. We don't want strings to stretch or compress, or we don't want the rods to compress, and we don't want them to dissipate energy. There should be no friction on this. So the first method that we use to solve these problems, method 1, which I don't like, but we will still see, because method 3, what I'm saying right, is actually a version of this. Method 1 is simply the length of the string is constant. The best way to learn constraint, right, is by examples. Frankly speaking, there's not much of a theory. You search anywhere, you'll not find anything. You'll just get examples. So listen carefully, because some of you still have that concept like, because my theory is bad, I'm not able to do questions. What you're not realizing is your theory will never be good. You understood something 60-70%, start solving questions. When you get stuck, you go back, revise your theory or get your doubts solved. Then your theory improves. By solving more questions, your theory improves. There is a limit how much you can improve your theory by reading. You can read it once, twice, thrice, 10 times. It won't cross maybe a 60-70% threshold. You have to solve a lot of problems in order to get your theory straight. Now, what is this first method? Consider we have a pulley here. We have a block A and we have a block B. Let this length be X and let this length be Y. So we know X plus Y is equal to L, where L is the length of the string. Now, no matter how much A and B moves, right, the length of the string will not change. So differentiate with time. And you get dx by dt, dy by dt is equal to 0. Now understand here, whenever X moves, which block is changing? Whenever A moves, A changes, right? So this is the velocity of A. So because whenever A is moving, X changes. Whenever B moves, Y changes. So velocity of A plus velocity of B is equal to 0. This thing is kind of obvious. We know if A goes up, B comes down. Or similarly, if B comes down, so A goes up. So here the negative indicates A and B are going in opposite direction with same magnitude. Easy stuff. So this thing is actually a pretty basic question. So it is kind of obvious. I know if A goes up, the B has to come down. But let's see what happens if I put more strings. Do have a look at this. So basically the method 1 is simply you label different length of the strings as x1, x2, x3, x4, any number of strings. And then you say the total length of the string is constant, and then differentiate. You see which velocity of the block will change which variable and accordingly substitute. Any doubts on this example? Ali, clear with this? Aryan, got this? Maulika, Ritu, clear na? Ritu, clear, right? Yeah. Mehan, Vartika, clear? Venkatesh, got this? Perfect. Now, let me take one more example. What if we have A like this, 3 blocks. And now I want to find the relation between them. So let's say this is X. If that is X, let this length be Y. This length is also Y, and this length is Z. So from here we can see the total length of the string. Kind of, we're actually neglecting this top part of the strings, because that will not change anyways. X plus 2Y plus Z is equal to L. Differentiate with respect to time. Then this will be dx by dt plus 2 times dy by dt plus dz by dt. L is anyway constant to 0. So this is nothing but velocity of A plus 2 times velocity of B plus velocity of C is equal to 0. Example, if someone had given you the numbers, let's say someone had given you this is going with 3 meters per second, B is going down with 2 meters per second, and you want to find VC ka velocity. Now, substituting in this formula, let's keep the convention simple, up positive, down negative. A is going up. VA bar plus 2 VB bar plus VC bar is 0. So A is going up, so this is plus 3. B is going down, so minus 2. And this is VC bar is 0. That would be VC bar is equal to 1. Plus indicates C is going upward. Are you getting this? If you see, this is not that obvious, right? Unlike the previous example, it is really not that obvious that A is going up with 3, B is coming down with the C will go with up with 1. Still, you can guess a bit, but it is not that obvious. Have a look at the second example. These problems can be done with method 2 quite faster, but then again, let's learn method 1 a bit because it will be useful when we try to. There are certain type of problems where method 2 fails. Check out this logic, what we did here. Any confusion? Anyone not clear with this? Please ask.
Sir, but in this example, if the velocity of A is 3 meters per second, the velocity of B is dependent on A. It should be 1.5 and then the velocity of C.
What will be C then? C will be at rest according to you.
Achha.
I don't know.
So the acceleration will depend on, I understood.
The moment you say 1.5, you are decided that C is at rest. Clear? So here, the velocity of A will depend on both B and C. All clear with this? Can I go ahead? Ali, clear na? Udayan, Vidyut? Anika, got this? Niranjan, Abhinav?
Yes.
Neil, clear na? Perfect. Let's see a question. Now, if you observe one thing, the mass of the blocks doesn't matter. So when I say the speed is 3 meters per second, somehow you got 3. Don't worry about that right now. There might be some other external force acting on the system which we are not aware of, but the constants will always work. What if I have 4 of them? Let's say A is going with 1 meter per second. B is coming down with 3 meter per second. C is going up with 1 meter per second. What is the velocity of D? Hmm. So if you just take this length as X, this is Y, this is Y, this is Z, this is Z, and this is some W. We get X plus 2Y plus 2Z plus W is length L. Differentiate with respect to time. Then this would give you VA plus 2VB plus 2VC plus VD is equal to 0. This should be 1 plus 2 into minus 3 plus 2 into 1 plus VD is 0. This will be 2 plus 1, 3, and this is minus 6. So VD is equal to 3 meter per second upward. Plus indicates upward. Check. Yeah. People who didn't get 3, please check. Where did you mess up?
So,
Abhinav.
so we can take either upwards or downwards, like positive. or-
Yeah, doesn't matter. Doesn't matter. You can take all up as positive or all down as negative. You'll just get an overall. You're just multiplying the minus sign overall, so it doesn't matter. Easy. Anyone not clear with this? Next one. Find velocity of B at this instant. How do you do this?
Sir, will the B block go up?
Yeah, B is on the ground. B won't fly. B is always in contact with ground. Aditya, you're right. Ronak, you're wrong. Yasha, you're wrong. Anika, you're wrong. Arjun, wrong. Niranjan, you're wrong. Aryan, you are wrong. Right, Yasha. See. First of all, let's let this distance be x, because whenever b moves, what changes is x. And let this distance be y. And this distance be h. Now remember, h is constant, h does not change. H is some variable you have taken. Now, the length of the string will be, this would be root over x square plus h square plus y. So length of the string is root over x square plus h square plus y. Differentiate both sides with time. LHS will be 0. This will be 1 by 2 root x square plus h square, and then differentiate inside will be 2x dx by dt plus dy by dt. Now from that triangle here, 2 will cancel, x by root over x square plus h square. And this would be, remember, minus db. Why? Because x is decreasing. Since x is decreasing, dx by dt, velocity of b is minus dx by dt. If x is increasing, it will be plus dy by dt. So that is one thing you should know in differentiation. Plus dy by dt is velocity of a. Y is increasing, so a is positive. So, and this thing is nothing but cos theta. BA is nothing but u. So VB is equal to u by cos theta. Check. It's not u cos theta. The velocity of the block along the string should be the same as the block A. And you should, someone has taken component, that's what you're doing. B is actually going like this. So B ka component in this direction should be equal to A ka component. So VB cos theta will be UA. But still, sometimes exam may in a flow we do a mistake. So this is how the method 2 works. You take the length of the strings and differentiate and finish it off. The problem starts when you have multiple strings, it starts getting confusing. So that's where method 2 comes, which actually is quite more convenient than this. It doesn't work in few situations. For that, we will combine method 1 and 2 and solve. We'll see that. Clear with this? Any doubts on this problem? Clear? Next one. Now, method 2. You'll find different names for this virtual work method. I like to call it power method. So what is the idea behind this? The idea behind this method is, first of all, since we consider ideal strings, ideal strings transfer energy from one point to another point. So whenever you say block A is losing energy, that energy must be going to some other block. The string itself does not consume any energy. Ideal strings transfer energy from one point to another. Or from one system to another. Therefore, the total work done by tension is 0. So we can say the total power transferred power due to tension is 0. Now, and we know what is power. Power is nothing but rate of change of work. And we also know work is nothing but F bar dot displacement ds bar. And ds by dt becomes velocity. This is the formula for power, force dot v bar dot product. And strings don't take energy or they don't contribute any energy. So how do we go ahead from here? Now, before going ahead a bit, we need to talk about something called tension. So what is this tension? So this tension, whenever you have a block or a system connected to a string, let's say you have a block of mass m. This is what we call as free body diagrams later on, but a basic idea, you can figure it out. So the string is pulling the block up. So T here is the tension. The tension force due to the string. Remember, strings always pull, strings never push. So whenever you connected a block to a string, you can always be sure the string is always pushing. Just to give an example, think of like this. Let's say we have a rope like this, right? And someone is holding this and is pulling it. So if the person is pulling the string, so and if you look at this person here, the string pulls him. You pull the string pulls you. I know, kind of obvious, but better put it down. You will always understand when you're putting a string, always it pulls. If you pull the string, it pulls back. Strings will always pull. The same thing if this person tries to push. And I'm drawing a little weirdly. What? How should I show that case pushing hard? There. If the person is pushing, the moment we push the string becomes loose actually. There'll be no tension inside it. The string becomes slack. So remember this thing, strings will never push, strings will always pull. That is one thing you should know. Have a look at this bit. So this is a little about tension. So strings always pull, and this is the basis we'll use it even in free body diagrams, the next part. All clear with this?
Sir,
So
can
whenever you talk about
give a
strings,
page to the for a minute?
what happened?
Sir,
Previous
can you
page.
go to the that's the thank you.
Then, any doubts on this page? Man pulling the string, man pushing the string. Next thing. So now in this method, basically the total power due to tension is 0. Therefore, if you have multiple blocks and multiple systems, T1 dot V1 bar plus T2 dot V2 bar plus so on till Tn dot Vn bar is equal to 0. So this Tn is the tension in the nth block. Vn is the velocity of nth block. Example. Let's take that simple example which we did. Now see, this is what we do in these kind of questions. And let's say is step 1. Label the tensions on each string. Step 2, find power on each block. Label the tensions and velocities power on each. And step 3, total power should be 0. So let's say for simplicity, A is going up with 1 meter per second. B is going down with 2 meter per second. And VC, I don't know. So step 1, label the tensions. So let this be T. Now see, it is the same string. This entire string is same. So this tension will be T, this tension will be T, this tension will be T. So power on A will be T into 1, both are in the same direction. Power on B, there are 2 strings pulling up, so 2T into -2 because it is down. Power on C, T into VC. I don't know the direction, I'll assume it is positive. The total power would be T into 1 plus -4T plus T into VC is equal to 0. This gives me VC is equal to 3 meter per second. You just get the velocities, tensions, multiply tension into velocity. If it is there at an angle, then you apply TV cos theta. Remember, this is a dot product. In this case, luckily, since they're in the same direction, you just multiply T into V and whatever. Let me show you one more example. But these are the 3 steps you do. Label the tensions, find the power on each block, and then find the total power is 0. Let me take the second example. Can I turn the page? The second example which we did. So let this tension be T. This guy is going with U. This tension is T, and this is going with VB. So power on V will be T VB cos theta. And this will be T into minus U is equal to 0. VB is equal to U by cos theta. Faster? Find length, differentiate, kuch bhi nahi karna hai. Just take this and multiply and you're done. You get the answer fast. Suppose if I give you like this, abhi dekho, isme method 1 will be a mess. Why? Length of the string is constant. Which length will you take? Will you take this length or will you take this length? Both are right, but it will be quite complex to observe, method 1 in this thing. When you have multiple strings, you can still apply, but it becomes quite confusing, like which length should I take exactly? But if you observe this thing, let's say B is going down with 2 meters per second. See, your life becomes so easy. Assume this part is tension T. Listen carefully, everyone. If this is tension T, this entire thing is the same string. So this is also tension T, agreed? Then what will be this tension here? 2T, na? Because two strings are pulling one string here. I hope you're able to see that. I'll call this pulley 1 and pulley 2. If you look at pulley 2, this one string on the top, and there are two strings at this thing here. So if I call this T and T, this should be 2T. And we consider all pulleys are massless. We consider smooth, massless pulleys. So once you have done that, if this is 2T, this entire string will be 2T. So this guy is also 2T. A ka velocity, I don't know, I'll just assume up. So power will be 2T into VA plus T into minus 2 is equal to 0. We get VA is equal to 1 meter per second. Are you getting this? This method is pretty, foolproof basically. You will get answers quite fast. Just get the tensions, multiply and finish it off. But there is one drawback. We'll see what is that. But questions are quite easy to handle. Check out these examples. Method 2 will give you answers for maximum number of problems. But they will harass you though. There will be some 10% of the problems where you need to combine 1 and 2. Any doubts on this? Your cams are off without a reason more than 5-6 minutes. I'll be removing you from the classroom. I already kicked 2 people out. It is fun. But I know I should say I'm feeling sad about kicking people, but you guys making me evil. What happened, Aditya? Forgot to switch on the game. You're eating cake secretly without showing us. Let's see a question. Now, here a few important things. This method, right, fails. Method 2 gives incomplete answers. If there are other forces involved. Responsible for transfer of energy. Remember, the whole logic we used was the total power transferred by strings are 0. But what if there are other forces like normal reaction, friction, and all that stuff are there? They are going to mess up the whole thing. So if you have forces other than strings, it will be a problem. Other forces responsible for energy transfer. We will see these cases later on. Second thing, method 2 is valid only for velocities. Now see, I'll write these points, but the point, you know what, you will understand the English behind this, but you'll never understand what the hell it actually means. The best way to learn is I give a problem, you do a mistake, then I explain, then it'll click, oh shit, this is what was the statement meaning is. This is the misconception people have. They think my concept is bad, that's why I can't solve the questions. Until you start solving, you never get the concept. It's valid for velocities. Velocities only, and not for accelerations. And can be used for accelerations. Only if angle between tension and velocities are not changing. I know the points look a little weird. It's okay, just read and understand them. When we see problems, you'll get the context of it. Angle between velocity and tension is constant. Let's do some problems and then we'll do these weird cases also. Seriously, where is this Ali? I kicked him out, he didn't come back. Did he feel bad, kya? Or he slept off? Let's say a question. Let's say a question. Easy one. B is going down with U. Find VB. Find VA. Questions are big, answers are small. Keep going. We'll finish off constraints by Friday. Next week we'll start off with free body diagrams and blocks and all that stuff. Okay, most of you got the answer. First one, what do you do? Step 1, label the tension. So, sir, which one to take T? Doesn't matter. You can take any one as T. I'll take this as T. So if this is T, this is T, this will be 2T. If you have taken T on the top, no, then it will be T by 2, T by 4, T by 8. It will become half, half, half. If you go from down, it will be double, double. So this is 2T, this is 4T, this is 8T, and this is 8T. Let A ka velocity be VA upward. Then power will be 8T into VA plus T into minus U is 0. So VA is equal to U by 8. Plus indicates the direction I have taken is right. Easy. Finish on the next one. I'll give you a minute. U by 4. Nah, Yasha, you are right. Adrit, you are right. Anika, you are right. Anusha, you are right. Aditya, Arona. Yeah, most of you got it. Easy stuff. Finish it off. I'll give you a minute. No, Rehan, that's not right. Rehan, that's wrong. Neil, you're wrong. Yeah, Udyan, that is right. No, Ritu. I think somewhere you're adding tensions wrong, everyone. See, if you take this is T, this is T, this will be 2T, then this will be 2T, this will be 4T, this will be 4T. So what's the total tension on B? 70, na? 70 VB plus T into U is equal to 0. So VB is equal to minus U by 7. It is going down. Yeah. Understood? You have to take the total tension acting on B. So there are 7 times the tension there. Yes, you need to add all the tensions. This is what I was saying. You couldn't have done this with method 1. It would have been a mess. Check. Easy. Any doubts? Clear, na? Ritu got your mistake? Venkatesh, clear?
Yes, I got it.
Malika, clear, na? Palaksh, clear. Next one. Let's do this guy. Ta-da. The man is pulling the rope from both the sides with a constant speed u. Matlab he's catching both the sides and is pulling with you. Find the velocity of the block. Just to give you a key context, he's pulling this side with u and this side also with you. And I'm asking you velocity of this guy. Try, you got a minute or two. U by 6. Aditya, you are right. Rehan, you're wrong. Leon wrong. Adrit wrong. Be careful. There are 2 different strings here. I don't know whether you observed it or not. Right, Yasha? You got it right. You have 2 answers, everyone. So first of all, try to understand. You should always take the string of free body diagram of string ka thing. So this is, start with any one side. If I say this is tension T, now see this entire thing is the same string. That is the same string. So this is tension T, this is tension T, this is tension T, this is tension T, this is T, and this is T. This guy will be 2T. So on both the sides is not holding with the same tension. The tension is different on both the sides. That is the thing. It is not T and D on both the sides. That you must have done the mistake. So if you look at on the power on the right hand side and the left hand side, this will be minus T into U. This is minus 2T into U, and this guy will be 1, 2, 3, 4, 5, 6. There are 6 tensions here. 1, 2, 3, 4, 5, 6, and this power will be 60 into V. So if you add all this, you end up with minus 3TU plus 60V is equal to 0. So we get V is equal to U by 2. Check. Easy.
Sir, I did this, sir, but won't there be another tension in the string? Like, since the
Where?
lower pulley is being pulled by two tensions, the
Where?
tension on the mass of blocking would be 2T upwards.
Which one you're talking about? Which pulley? This pulley.
So for all the pulleys connected to the block.
So this is only not 2T. Where did you get this 2T from?
Acha, okay, understood.
Isn't that the same 2T there? How did you get 2T there? Because this was T and T. That only you're calling this as 2T, na?
Okay, sir.
You can do that. See, you are saying I'll find tension in this part, right? I am saying that pulley and this part is only one part. So end of the day, the same 2T we are talking about. All clear with this? Easy? Got this? So the main thing is to figure out the tensions properly. Next one. Any doubts? Vartika, clear with this? Arjun, got this?
Yes, sir.
Let's say we have a block here.
Sir, can you go to the previous slide just for a minute? Yes, sir.
Find VB. That string went up and came back to the pulley again. The inclined angle is 60 degrees. Okay, most of you got some number. Let's see. See, first thing, tension is T. It is the same string. Tension is T, tension is T, and tension is T. Now, when you say power is T, V cos theta, what is theta? Angle between tension and velocity. Theta is the angle between tension and velocity. It is not the angle of inclination. The 60 degrees is useless. In case you have used it, you fell into a trap. This is angle between tension and velocity. In this case, tension and velocity both are parallel. So here the theta is useless. So the power would be T into T, that will be 3T into VB. So we get VB is equal to minus 2 by 3. Minus indicates it is going downward. So be careful. It's not much, but I have seen people in a flow rate, they write T into 2 into cos 60. Just be careful. That theta is the angle between tension and velocity. It has nothing to do with the inclination. Yeah, most of you got it right. None of you did that mistake. Good. Better to be careful. Exam, anything happens. 2 into 2 becomes 5 also. Clear? Easy? Next one. Ali, clear now? Vastika, got this? Arjun, clear so far? Let's say we have a block here. We have a block here. Let's say this is A, this is B, this is theta 2, and this is theta 1. This is going with VA, this is going with VB. Find VA by VB. This is the easy one. Next one is an actual question. Let's see. Let's see. So let this be tension T. Let this be tension T. So this power will be T VB cos theta 2. This can be written as T minus VA cos theta 1. You can just reverse VA ka direction and say TV minus cos theta 1, or you can say TVA cos 180 minus theta 1. Both are same. So you end up with VB by VA is cos theta 1 by cos theta 2. You can just reverse it. Easy. This thing can be written as TVA cos 180 minus theta. Remember, angle between two vectors is tail to tail. Should actually take 180 minus theta 1. Or you can simply, what you can do now, write VA backward minus VA, and then say angle between T and minus VA is theta 1. Same thing. You'll just get a minus sign there. Easy one. Same question. What if we have a ring here? We have a block A here and like this. So now we have a ring also which is moving. The ring slides on a horizontal rod. So velocity of the ring is, let's say, 2 meter per second. This is 30. This is 60. And B is going with 3 meter per second. Find velocity at this instant. And here now, if you see the string is passing through the ring, okay? It is not tied to the ring. Find VA. You're getting told now there are total 3 things moving. A is moving, B is moving, ring is moving. Find VA at this instant. This is a better version of the previous question. Try. You got a minute or two. Now we'll make things a little tougher. You won't get a beautiful answer. Try. Root 3 plus 1. 2 by 4 plus root 3 by 3. 2 minus root 3. 1 plus 2 root 3 by root 3. I'm not sure. There are so many root 3s here. Some of you are definitely wrong. Most of your answers, everyone is different. Minus 5 by root 3. That looks definitely wrong. 2 root 3 plus 1. 2 by 3 root 3 plus 2. Let's see. First thing, the free body diagram. Label the tensions. There's only one string here, so this would be tension T. This would be tension T. So ring has actually 2 tensions. You are getting it. Wherever the ring is being touched by the string, you have a tension there. Remember what did I say? Strings always pull. So if you just look at the ring here, so at this point you have a tension T here, and this angle is 30 degree. This is tension T here, and this angle is 60 degree. So the total power on the string will be T cos 60 minus T cos 30 into 2. I have taken the tension on the right hand side. This is the power on the ring. I hope people did this. If you have not done this, you definitely got a wrong answer. Now the total power, if you take, that will be T VA cos 30 plus power on the ring will be T cos 60, that is T by 2 minus T root 3 by 2 into 2 plus tension minus VB, that will be cos 120. I'll just put it as a minus sign because it is backward, is equal to 0. Tension cancels everywhere. We get VA cos 30 is root 3 by 2 plus 1 minus root 3 minus VB is 3 by 2 is 0. So we get VA is equal to, how much is this guy? 1 minus 3 by 2 is minus half minus root 3. It will go that side, so we'll get root 3 plus half into 2 by root 3. Multiply 2 inside. So this will be 2 plus 1 by root 3. Wait a second. Hope I didn't go for any calculations. Who got this? 2 root 3 plus 1. Then you're pretty close and you messed up. 2 root 3. Yasha, I think you got it. 2 root 3 plus 1. Yeah, Yasha got it right. Adrit, you also got it right. Some of you
Sir,
are pretty close.
I did it by
Hmm.
different method actually.
What did you do?
I stopped the ring and took the velocity, relative velocity.
Chalega, works. That works. Because end of the day, the power rate doesn't matter on what velocity you're taking. It works. What they are suggesting, alternate method. I'll turn the page. So just an alternate thing. So what they're saying, put the observer on the ring. Solve with respect to ring. Then the whole question becomes as if like the first problem. So 2 is going forward now. So this guy will be VA minus 2. And B becomes speed of 1 meter per second. This is velocity of B with respect to C. This is the velocity of A with respect to C. And then use the first method here, theta 1, theta 2. And finish it off. TVA minus 2 cos theta 1 minus T 1 cos theta 2. So using relative velocity is much faster, but this is actually what is happening. Check it out. I'm actually more interested in this part, okay? That whenever the string passes through a ring, you have to take 2 tensions. That idea is important. Most people don't understand what to do with that ring, and they don't understand because it is not tied here, no? It is passing through. But still it behaves as if there are 2 tensions pulling it down at an angles. That would be a useful concept. Put it up. Any doubts on this, please ask. Can I turn the page? Palak, clear, na? Udyan, clear? Rehan, Ronak, got this? Next one. This is B and this is A, and A is going with the speed of U. So we need to find VB. This is the point P and this is the point Q. P and Q are points on the string. You took a marker and you marked 2 points on the string. Find VB, VP, VQ. Get this. Okay, get the rest. First part is fine. Find VP and VQ also. PU by 4. Yeah. How do you find P and Q? Think, I'll show you in a minute. Try. BB is easy. U by 2, yeah. P and Q, I have to see when I don't remember the answer. First part. This is tension, 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 tension. So basically from here we get 4T VB minus 3T VA is equal to 0. So VB is equal to 3U by 4. Straightforward, no? This was easy. The problem, whenever you want to find velocity in the middle of the strings, like P and Q, the logic that we have to use is, understand what is the whole method that we are using. We are saying the power transmitted in a string is 0. So don't take the full string, just take the part where you want to find the velocity. So this is what I meant. Cut it here. You want to find the velocity at P, cut it at P. So imagine this is the method we use. Imagine string is cut at P. Right? And a block is connected. Because the string doesn't care whether you're giving energy to a block or you're giving energy to someone else. And connect a block. That will be easy for you to understand. So you're just assuming as if there is a scenario like this. Let's call it C. So this is A, this is B, and this is C. So the whole question has become like, this guy is going with VA, this guy is going with VB, and this guy is going with some VP. Tension, 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 and this is tension. So the idea behind this thing is this part of the string, the total power with this string is 0, isn't it? The total power given by any part of the string is 0. So it doesn't matter whether you're connected to a full block or this part of it. So if you write the power here, what do we get? 2t into VB plus minus t into VP minus t into VA. VB ka value just now we calculated 3u by 4. T gets cancelled. 2 into 3u by 4 minus VP, and A is already u is 0. How much is this? U by 2. And the direction I assumed is right. Check. Right, Yasha. Same thing if you try to do for the other guy. So now the block is connected here. And just draw it in the next page. So whenever they give you ask you velocity at any middle point in the strings, this is how you do. Assume there's a small block there. See, this is your point Q. This will keep it simple, like you'll chances of doing a mistakes will decrease. Tension, because the whole concept is the total power by a full string, the total power by a part of the string is still 0. It doesn't matter. This guy is going with u, and this guy is going with 3u by 4. So the power would be 2t, 3u by 4 t pq minus t into u is 0. 3t into u is 0. This would be t gets cancelled. 3u by 2 minus 3u plus vq. So I got vq is minus 3 by 2, meaning I took the direction wrong. It is not going right, it is going left. So the signs will take care of it. You just assume any direction you want. No, plus only, no? Plus only, plus only. In case if you had got a minus sign, means it is going left. The signs take care of it. Have a look at the steps. I hope this logic was clear. So doesn't matter which part of the string you're cutting. You can always cut it there, assume a block. Someone can say like this thing, sir, why are you not taking the lower part of the string? Chalega na, you can take the lower part of the string also. That also works. You either take the upper part or the lower part. The answer will remain same. So basically the power transmitted by this string to the lower part of the string will be equal. That's the whole theme behind it. Power transmitted by a part of the string or a full string is still 0. Have a look at this. Clear? Any doubts on this? Can I go ahead? Vidyut, clear now? Kartika, Venkatesh, got this?
Yes.
Neil, Niranjan? Sure. Next one. Abhinav, clear now?
Yes. Sir.
We have a ring here. There is a string connected like this. And there is a block connected like this. Let's call this A and let's call this B. This distance is h. This angle is theta. And the ring is going with u speed. Ring slides horizontally with constant speed u. find velocity and acceleration of A. At this instant. This is a good one, right? Velocity is easy. Get the acceleration back. Try. You got 3 minutes. Nah. Velocity. Nah, Swastika. Check it out again. You messed up the angle somewhere. The velocity part is easy, everyone. Tension. This is VA. This is tension. That would be T U cos theta plus T into minus VA is 0. We get VA is equal to U cos theta. ये easy था. Get the acceleration of block A. Tadrit, complete it, na? That is not the answer. What you wrote was right, but then you have to complete that. Aditya, you might be right. Check karna padega. Ronak, that's a blunder. Now I'll tell you what most people do. They say VA is U cos theta. Differentiate with time. And they'll say dVA by dt is equal to cos theta du by dt. And you said U is constant, so this term is 0. And then say therefore acceleration of A is equal to 0. This is a blunder. This is wrong. This is a blunder. Reason, you differentiated, idea was right. There you goofed up the differentiation. You said VA is U cos theta. Who told you theta is constant? Who told you theta is constant? So this is actually dVA by dt is equal to U cos ka differential minus sine theta d theta by dt plus cos theta du by dt. Second term is 0, I agree. This term is 0. But the first term is not 0. Now the problem here is I don't know what is d theta by dt. Theta I know, I don't know d theta by dt. Now coming back to this question there, if you'll observe, the ring is here. This is theta. And in this triangle, the h is given here, let this distance be x. So we get from here tan theta is equal to h by x. Differentiate both sides with time. Tan ka differential will be sec square theta d theta by dt here. Here you are getting d theta by dt from. This would be minus h by x square into dx by dt, chain rule. So from here we get d theta by dt is equal to minus h by x square sec square theta, and dx by dt is nothing but, remember here x is decreasing and this is the velocity of b. So dx by dt would be minus vb. So d theta by dt would be h vb, and what is x? X is h tan theta. X also I don't know, I need to substitute here. So that would be h square tan square theta into sec square theta. Sin, that will be sine square theta. X is h square theta tan square theta sec square theta. So that is cos square theta, sine by cos square. So that will be sine square theta vb by h sine square theta. Sine square theta by cos square theta, cos नहीं ना, cancel नहीं होगा वो.
Sir, the x will be h by tan theta.
हाँ. Then tan square theta by sec square theta. So that would be vb sine square theta by h. That is your d theta by dt. And this would be acceleration of A is equal to minus u sine theta d theta by dt is velocity of B sine square theta by h. So this would be minus u sine theta, and what is VB? VB is u cos, VB is u only. Yeah, VB is u only. So that will be minus u square sine cube theta by h. That is the acceleration of A. Check. That is the acceleration. And this is a trap. This is what I said the second point, if you remember. You can't use this power ka method, you know, TV cos theta is constant for accelerations if angle is changing. So what most people do in a hurry, right? They write T into acceleration of A is equal to T into acceleration of B. Blunder it is. It doesn't work. This method is only valid for velocities. If theta is changing, find velocity and then differentiate and get the d theta by dt. Check this out. In this entire problem, the main catch is this d theta by dt ka part. So people have the perception that A ka B ka speed is constant, the Y is changing because theta is changing. This would be the acceleration at that instant. Check. Any step you didn't get, please ask. It's a good one. This will be proper advanced question. Mostly in a more than one choice question. One of the option. They'll ask you speed, they'll ask you acceleration. Acceleration में दो option होगा. One is 0 and one is this. People will put 0 and be happy about it. So the important thing, right? It's not always about how to get the right answer, but it should also be clear like what kind of mistakes you can do in the exam. And that's why, you know, I keep adding these kind of wrong things, because this is one thing that I observed. Most people know how to do, but in that exam ka tension, right? They don't realize, you know, out of the habit, you just do it normally, and when the moment you see the answer, you are just happy and you mark it. So you should know, array, in this question, this is the mistake I can do. So if you have that realization, you'll be more careful. You can decrease your silly mistakes. So be very careful when you are, see, we are here to crack the exam. So most people have the misconception, you know, if my subject is good, I'll get marks. Subject is only one part of the strategy. You should be more self-aware, like what kind of mistakes I do, how do I behave in the exam? Why do I get tensed? If I black out, what should I do? These strategies also should be very clear. You should be very calm in the exam. The subject will make you more stronger. That is mandatory, but other factors do play a role. Clear with this? Let's see one more like this. Can I turn the page? Abhinav, clear with this?
Yes.
Perfect. Next one. We have a pulley. We have a block. We have a pulley. Let's say this is small m. This is small m. This angle is theta and this angle is theta, and this is capital M. And both these blocks are going with U. Constant, and this guy is also going down with U. Constant. And distance between this thing is D. Matlab, this distance is D. Find the acceleration of the block at this instant. Finish off, last one for the day. Once the pace starts 2 tracks, right, we'll bump up our timings. That time we will have a class of 2.5 hours with a small break in the middle of 5-10 minutes. The timings will become 5:30 to 8:15 kind of things. But for now, they're going chilled out, so let's go cool. Right now, with your seniors, they have gone mad completely. I think I told you this. They're running 5 tracks of chemistry. Physics फिर भी चल रहा है, chemistry 5 tracks shit रहे. What will you remember? उसमें भी 2-3 track inorganic ही होगा. It's like theta, tan, theta. You got such a beautiful answer without the velocity. I asked you for acceleration, not the speed. U by cos. I asked you acceleration, everyone. Why are you guys finding velocities? Velocity to find karna hai, but I didn't ask you for that. Find the acceleration of the middle block at this instant. Velocity is a part of the game. And your dimensions are not matching. If you think about it, acceleration should be not U. It will be something like U square by distance, right? Think, try. This and the previous one are quite related. Both are based on the same idea that theta is changing. Try. You got 3 minutes. It's a good question. It's a worthy question. Just give it a try. Get some water and come. Any answers? First, you have to find velocity. वो तो compulsory है. And then you have to differentiate. You get d theta by dt. Then you have to find d theta by dt. The theme is the same. Try. Leave another 1-2 minutes, and I'll show you. I'll send you a small sheet on the string constraints today. You can try that before Friday. Friday we will see the method 3 and rigid body constraints. These are good ones. So these are the traps. Velocity part was easy. The moment acceleration is coming, it gets messed up. First, let's find the velocity. Most of you got it. Tension, 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 and let this guy go with V. Then minus 2t u plus 2t cos theta. That's the total tension in the vertical direction into V. We get V is equal to u by cos theta or u sec theta. That's your velocity. And this triangle which you have, let this be theta. This guy is d by 2. And let this thing be y. So I know tan theta is equal to d by 2y. Differentiate on both sides. X square theta d theta by dt is equal to minus d by 2y square dy by dt. So from here we get d theta by dt is equal to minus d by 2y square secant square theta, and dy by dt is nothing but minus v. So d theta by dt, and v is nothing but u secant theta. So u sec theta into d by 2 sec square theta, and y is how much? Y is d by 2 tan theta. So that would be d square by 4 tan square theta. 1 d will cancel. 2 u tan square theta by d sec theta. You can further simplify, but okay, you got the idea here. So there, this is how you get d theta by dt. Then what you do here, differentiate. I'll do it in the next page. So we got v is equal to u sec theta. If you differentiate this guy, this will give me dv by dt. U is constant, so it will come out. Sec ka differential is sec theta tan theta d theta by dt. This would be the acceleration of the middle block. This will be u sec theta tan theta, and bring this d theta by dt. That is 2u tan square theta by d secant theta. Sec gets cancelled off. We end up with 2u square by d tan cube theta. ठीक था, आंसर इतना भी bad नहीं था. Check your calculations. Who got this right? Adrit, you got tan square, na? 2 be missing था तेरा. Yasha, you got sine. Anika, check. Maybe I could be wrong. See where it went wrong. Please check out this step first. Main thing is getting the d theta by dt is the headache. Once you got that, it is easy to handle from there. All clear with this? Do check it out. Clear? Let's do one last question, then we'll wrap it up. Can I turn the page? Any doubts on this? Anyone not convinced, not clear? Please ask. Anusha, Ritu, Swastika, clear? Anika, got this now? Maulika, Mehan, Palak, Abhinav, all clear?
Yes.
Perfect. Last one. We have two parallel rods. And we have a point over here, which is fixed. So we have a ring here, we have a ring here. Then you took a string connected from here, passing through this ring, and it is attached here. This is ring A, which is going down with a constant speed u. This is ring B, which is going up with some speed Vb, which I don't know. This angle is theta. At this instant, the distance between them is d. So the string is fixed at O. So one end of the string is fixed at O. Passes through A. So it is not tied to A. Passes through A and attached to B and tied to B. So the other end of the string is tied to B. I hope you're getting how it is. That means if I show you the diagram now, after some time, A will come here, B will come here, string will become like this. Now. Able to visualize as you're pulling this ring down, the string is actually moving up. The diagram would kind of look like this. Initially, it was like this. And the ring has come somewhere here. Then the string has become like this. You're getting how it is going? As you're pulling this ring down, the B ring will go up to compensate. This is going up. So the question is find velocity of B. And homework question, I'll give you this, you to try, find acceleration of B. Now, you know, acceleration of B, again, all that story, d theta by dt and stuff, that you try at home. But right now, let's do velocity of B. That is an easy one. U by cos theta minus u. I don't know the answer. देखना पड़ेगा. U by cos theta minus u. That might be right. Finish off. Easy one. This is. The acceleration is fun. That you try down. Yeah, if you see method 2 is quite useful in that. We couldn't have done all these problems with that method 1. It would be a big mess. Method 2 has its own problems that we will discuss it in the next class. Like what are the issues where method 2 fails at? And then we'll see how to handle those problems. And then we'll go for rigid body constraints. Spaces send some TWT schedule. Check it out and see if there's space का any TWT schedule. मतलब they conduct a test every weekly or every alternate week ना, कुछ तो होगा ऐसा. उसका कुछ schedule है तो let me know, send it. Major test का schedule तो I know, it is in October, right?
Yes, sir.
वो ठीक है, but let's see. Where did they reach in pace right now? They finished constraints?
Yes.
We just finished wedge constraint.
Okay, I think they're like one class ahead. ठीक है, that is okay.
Sir, we are about to start friction.
Yeah, we are also.
Some of you are in a 3-year batch, I guess, ना? वो पहले जो batch start हो गया. Let's see, we'll catch up. Speed बढ़ाएंगे. How to do this thing? So this would be one tension, this would be the second tension, and this would be the tension. And this angle is theta, and this is velocity v. And if that is theta, this is actually a straight line. I didn't draw it properly. If that is theta, this is theta. So power would be T VB cos theta, and this power would be T cos theta minus T into V is 0. So we get VB is equal to V into 1 minus cos theta by V. That's it. Just find the tension on the ring. Like I said, ring will have two tensions now, up and at an angle theta. Take the vertical component, multiply with velocity, take V ka tension and finish it off. Check. Clear? So ठीक है, that's the last one for the day. So with that, we'll wrap it up. So next lesson we'll continue from here. So do make sure to revise the notes and come, and I'll be sending a small sheet of maybe 10-15 questions on constraints also, similar model, so you can have a little practice. Because I think constraints का इतना कुछ नहीं है booklets में and all, it is all scattered.